Ask it to write a program. Something simple, maybe a Python script to sort files in a folder by date. You press enter, and in seconds, it appears. Lines of syntactically perfect code, complete with comments, ready to run. And when you run it, it works. This feels like magic, like speaking to an oracle that understands the language of machines. It's a powerful tool that can build complex software structures from simple human language, constructing logical fortresses with astonishing speed. But then, you introduce a subtle flaw. Not a syntax error, but a logical one. The program now mislabels every file created on the last day of a month. You present this broken code back to the AI and ask it to find the bug. It might suggest changing a variable name or reformatting a loop, changes that are statistically common fixes for other problems. It's patching the walls when the foundation is cracked. The AI sees the code, but it doesn't see the problem. Why can it write a correct program from scratch, but not reason about an incorrect one? The answer begins in a thought experiment, a library containing every possible book. This is the Library of Babel, imagined by Jorge Luis Borges. An AI, specifically a large language model, is like a librarian who has read every single book in this infinite library. It hasn't understood them, but it has memorized the patterns. It knows which words are likely to follow other words, which sentences are likely to appear in which paragraphs. For code, it knows which tokens and functions are most likely to appear in a sequence to achieve a certain goal, because it has seen it millions of times before. It is the ultimate pattern matching machine. A bug, however, is not a pattern. A bug is a deviation from something the AI can't see: human intent. When you wrote the prompt, you had a goal, a mental picture of what the program should do. The code is just the shadow of that goal. A bug is when the shadow is distorted. The AI can see and analyze the shadow, the code itself, but it has no access to the original object casting it, your intention. Debugging is the act of realigning the code with this invisible intent. Computer scientist Judea Pearl proposed a ladder of causation to describe different levels of reasoning. The first rung is association, seeing. This is where today's AI lives. It can see that a certain error message is often associated with a certain type of code fix. It finds correlations. It knows that when the sky is dark and cloudy, rain is probable. But it doesn't understand why clouds cause rain. It's an incredibly powerful form of pattern recognition, but it's not reasoning. The second rung is intervention. Doing this is the world of a human debugger. We don't just observe the broken program, we poke it. We ask, what happens if I change this variable from 1 to 0? We run an experiment. This requires having a mental model of the system, a concept of cause and effect. You predict that changing one thing will cause a specific change somewhere else. The AI, in its current form, doesn't do things in this way. It just predicts the next most likely sequence of text based on what it's seen before. The third and highest rung is counterfactuals, imagining. This is the heart of finding a bug's root cause. After the program has crashed, you ask the crucial question, why? The answer is a counterfactual statement. The program crashed because this value was negative. If it had been positive, the program would have succeeded. You have to imagine a world that didn't happen to understand the world that did. This requires not just a model of the system, but the ability to reason about alternate possibilities, something our brains do effortlessly. When you read code and try to find a bug, You are running a simulation. Your brain's prefrontal cortex acts as a virtual processor. You hold the state of variables in your working memory. You trace the flow of loops. You execute the logic line by line inside your own mind. You are running the program on the most complex machine known, the one between your ears. This mental simulation is a direct implementation of interventional and counterfactual reasoning. An LLM doesn't have a prefrontal cortex. It has a matrix of weights and biases. The trickiest bugs are often novel. They are the strange edge cases, the unpredictable interactions between systems that no one has seen before. The AI's knowledge is based entirely on its training data, the code that has already been written. If it encounters a truly unique logical error, it has no direct precedent. It might find a similar-looking problem and apply a similar-looking solution, but it can't reason from first principles to solve something genuinely new, because it has no first principles to begin with, only patterns. Imagine the code is a finished building. The AI can walk around it, analyze the materials, measure the angles, and compare it to millions of other buildings it has seen. But it doesn't have the architect's original blueprint, the document that contains the intent. Debugging is the process of walking through the building with the blueprint in hand and spotting the differences. Wait, this wall isn't supposed to be here. This door should lead to a balcony. Without the blueprint of intent, the AI can only say whether the building looks like other buildings. This leads to a final, uncomfortable thought. Are these models simply sophisticated parrots? A parrot can be trained to perfectly replicate the phrase, "The sky is blue." It can even learn to say it when it sees the sky. That's association. But the parrot doesn't know what sky is or what blue means. An AI can write a flawless sorting algorithm because it has seen thousands of them. But does it understand what sorting is? The gap between mimicry and comprehension is where bugs live. For AI to truly debug, it may need to be more than a pattern matcher. It won't just need more data from the library of what is. It will need to build its own mental models. It will need to develop the ability to create sandboxes in its own mind, to run experiments, and to reason about worlds that could have been. It will need to climb the ladder of causation. The next leap forward isn't about writing code better. It's about understanding what code actually is, the fragile, imperfect shadow of a human idea. Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.